kind of two of the tests that we would do on water. So it's, I think, page 171. So we have two words. We have the words suspended solids and we have the words dissolved solids. So what are suspended solids?
Solids that don't dissolve in the liquid.
Yeah, so they're going to be there. Now, they could be ridiculously fine. How do you think, if I had a sample of dirty water, how would you figure out how many suspended solids you'd have?
Would you filter it?
You would.
And then you can see the stuff.
You absolutely would. So if you were going to filter it, what's the name of this funky funnel that we use?
Miss, are you supposed to be screen sharing?
Oh yeah, thanks so much, Cam. That will do it as I doodle away here by myself. So we have our little Buckner funnel and we have, I gave it away. We have our filter paper. So if you know the mass of your filter paper, you can figure out the mass of your suspended. How would you figure out then the dissolved solid? So I now have a sample of water in here. How do I figure out dissolved solids?
Evaporation or distillation.
Yeah, so you would heat and evaporate, and you would use your little evaporating dish, and you would get your little crystals. And again, as long as you've pre-weighed this, you can figure out then how much you have. So everybody in the room, so ordinary level lovelies, higher level honeys, everybody has to do the maths for suspended solids and dissolved solids. So suspended solids are insoluble substances and they're really fine particles, but they won't settle. So it wouldn't matter how long you leave your water sample sit there, they will still stay there. So cloudy water, sometimes it comes through our taps. There's loads of suspended solids in that, and they describe it as turbidity. If you can't see through it, then that sample has really, really high turbidity. If you can see through it, it has low turbidity or no turbidity at all. And obviously, if you have suspended solids in there, light can't get through, things can't photosynthesize, so that's not going to be a good thing. So it's caused by plant, animal, or inorganic matter. So little bits of slurry that get into your water, that would cause turbidity. And you've now told me, we obviously, when we do our flocculation and our settlement and even the filtration, that's going to remove suspended particles. So I'm just going to write that over here. So it's the flocculation, the settlement, and the filtration on the gravel beds. That gets rid of suspended solids for us. And to figure it out, we filter with filter paper weighed before and after, and we express our results in parts per million. So over here on the left, what these are is, this is commercial pictures, but this is water that's been filtered through Buckners under real high pressure, and you can see all the different colours of the crud that remains depending on your water sample. So slightly different to our filter paper, but we would see something similar. So sometimes you'll see in the question these words, total suspended solids. So TSS, but total suspended solids. Happy to move? Bob looks like he's not capable of moving at all today. There must have been good Xboxing or equivalent. Alrighty, so then we just get to our dissolved solids. They do what they say on the tin. They can affect both your colour and your taste, and you've told me estimated by evaporation with beaker or your dish, whatever it is that we use, weighed before and after. And again, we will express our results as parts per million. So the water we drink on this scale should be from here down. In terms of total dissolved solids.
And it's what we put in for dissolved solids.
Soluble solids dissolved in water. So the stuff down here at the bottom would be the stuff that they would use for your computer chips. There'd be nothing in it. So this may be the tap water that comes into your house, but if you then have your let me think what I want to say. Yeah, in Ireland we definitely would be somewhere around here for our water. That's just to show you. So on the bottom of page 172, you just have a little mini version of what we would do with our experiment. So we take a known volume of water. Is it okay to flip forward onto the little diagram that you have? Take silence.
No.
Nope. There you go.
Miss, is it expressed as a milligrams per litre?
Yeah.
Times one?
So we would, when we would do this, we would take 100 ml sample in total, and we would filter it, and then we take an aliquot of that and we would evaporate that, because it would take forever to evaporate 100. But we'd filter a bigger amount, and then we'd then work up. We now have whatever 10 mgs per 50 centimeter cubed. We would turn that in then into how many mgs per litre. So this is not here. So this is our little picture of it. So we would at each time we would know our volume of water. We would know that if we subtract mass 2 from mass 1, or mass 1 from mass 2, we would get our total suspended solids, and we just make sure we convert it to milligrams per litre. And down here with our evaporating dish, we would take mass 4 from mass 3, and then we would convert that up. So every time we would know how much volume that we're going to take. That's really important. So I'm going to give you some numbers now. Our filter paper was worth 0.30 grams. The mass of the dry filter paper after M2 was going to be 0.372. So you're going to now work out for me what our total suspended solids was in that instance. So we're all getting the 144 parts per million?
Yeah.
Okay, so then if we had our dish, our dish might be heavier, so we're going to go Don't think this is right.
Hey, did we do the total suspended solids yet?
Yeah, we just did. Here, I'll put it back for you. There's the total suspended was 144.
Got it.
Yeah, so this is now our total suspended. So,
I was only starting to take that down, though.
oh, apologies. The others have their numbers they can work away.
I think there's a bit for the massive suspended solids that's left out.
You're supposed to be doing that, Dan, you lazy daisy.
Oh.
You can do that math in your head.
I'll do it in my... Move on to dissolved now.
Thank you so much.
Thanks.
So what do we get for dissolved? I think this has to be by 10 because it's 100 centimeters cubed. So what do we get? Any takers?
0.159.
So 0.159 is our grams per 100. So I have to multiply that by 10 to turn it into grams per litre. Is that right? Yes. Multiply that by 1,000. 1590 mgs per litre. So 1590 parts per million. So the maths for this at both levels, it's going to be max 6 marks, I would say. So for Dan, they asked it for you, Dan, in the short questions in question 4. And for higher level, they can ask it in a question 3 on water. So not the titrations. And they can ask it as part of a water question in section B.
They give you the figures up.
Yeah.
So you don't.
So if you have a look at the bottom of page, must be 173 for you. That's the 2016 3E question. That's what they give to you. And you have to convert it to parts per million. So folks, that is us done with water treatment. The experiment will go on to my to-do list for when we get back to school. I'm an optimist. And the homework questions have pinged. So if there's any issues, you get back in touch. Alrighty? So we see each other tomorrow again?
Yeah.
Yeah.